Hey guys, and welcome back to my channel. And today's video, I'm going to be talking about the circuit design of these isolated power supplies for effects pedals from Caline Technologies. So for full disclosure, Caline did send me these power supplies free of charge to review. And I do have quite a few of these already, especially the previous versions. Two of them are actually running my pedal boards to this day. And these are just the newest versions, and the only difference is the cosmetic stuff. You can check up here in the corner of the playlist of all the different power supplies that I reviewed, and you can see some of the previous versions that had slightly different graphics on top and the USB port that was on the top part of the case there. They have removed that for the latest versions. It was nice to have, but I didn't think it was really necessary. Now, I have taken the covers off so that we can discuss the circuit design and how these work. And really the main reason why I'm doing this particular video, Caline not only asked me to talk about this, but I always thought that this was something to talk about, especially if you're looking for a pedal power supply. You see here on the box it says isolated power supply. And a lot of the products that you see online these days, they'll say isolated power supply, but when you get underneath the hood and you look at it, there's no isolation components whatsoever, and it's really a form of false advertising. And this video, I hope to dispel any of that notion or chatter about these particular power supplies, because they are truly isolated. And the way you can tell that they're isolated is when you see these little transformers inside. They're present on all three models, the 205, 206, and 207. And I'm going to quickly go over briefly, without getting too technical, how the circuit works and how it is designed to isolate the power coming in from your wall to the power going out to your pedals. So the way that these power supplies work is that we have the mains power coming in the power brick here, and it's taking 100 to 240 volts AC and then regulating it down to 18 volts DC and filtering it. We're then going to take that DC voltage, bring it in, and we want to isolate it. And the way we isolate it, we can't use DC voltage on a transformer, so we're going to put a circuit on here that converts the DC coming in to AC, and we're going to put that on this primary winding. On the other side of the transformer is your secondary winding. There's actually 4 of them here for the 1, 2, 3, 4, and then you have 4 of them here on the secondary for the other outputs for these output stages. And that's where you're going to get the isolation from each individual output stage, so that your pedals don't share the same ground plane. That's important. That basically breaks the ground loop. But before we get to that point, the secondary winding is going to have an AC voltage. We don't want AC, so we're going to convert that back to DC, and then we're going to add some filtering components to it. That way there's no noise, there's no buzzing or anything like that. Typically these kinds of circuits will induce some noise, so there's going to be some filtering components to get rid of that. When we have a slightly higher voltage than 9 volts is what we're going to get. In order to get that to 9 volts, that's what these little transistors are for. These transistors are actually linear voltage regulators, and they're going to take a slightly higher voltage incoming and regulate it down to 9 volts so that it's going to stay steady. And there's some filtering components on the output before it gets out to your pedal, even before you connect this wire, and that's pretty much it. So now we have isolation from the wall, and we also have isolation from each individual output stage. That is how they are doing it. And all 3 of these power supplies operate in this exact fashion. So now that we've established that these are true isolation power supplies, what's the difference between these budget options compared to a more well-known brand name, say Voodoo Labs or the Onespot or Cioks, for example? All those are very, very good power supplies. They're also very expensive. And they're all essentially doing the same thing, just maybe in a slightly different form factor. They don't have the wall wart necessarily. They'll have an IEC connector. This circuitry is built into the box itself here that normally you're seeing in this kind of a 2-part format, where it's the power brick here, and then you have the power distribution brick here with all the output ports here. The only difference, and I'm going to pick on the Cioks, for example, because I know this has this type of component. There's only one component difference, and the circuit design is all exactly the same. It's this linear voltage regulator that they do not use. What is happening here is that this linear voltage regulator, this is taking that rectified AC, which is slightly higher than 9 volts, for example, and it's going to regulate it down to the 9 volts on its output. And it works well, but they're not very energy efficient. These are not heat sinks, so that's going to severely limit the amount of output current. All these outputs, they're anywhere from 100 to 300. I think we have a couple high current ones, 500 milliamps on the 9 volt lines, but that's the most that you can draw before this linear voltage regulator gets too hot. That higher voltage incoming, well, it's got to go somewhere, and it's going to go in the form of heat. That's what makes these linear voltage regulators limited on the current that you can pull from them without having a major heat sink on them. And that is really the main limitation for these kinds of power supplies. Cioks, on the other hand, will use not a linear voltage regulator, but they will use what's called a DC to DC converter. And that chip that was running the USB, for example, is a DC to DC converter. And these type of chips are highly efficient. They don't have any waste heat dissipation, if any at all. And they can also push very high currents in the upwards of 1,000 milliamps, up as much as I've seen as 2,000 milliamps. Now, if you have a very power hungry pedal, then that is the power supply that you would want. But that's really the main difference. But when you use a chip like that, it adds more complexity to the circuit design. Those DC to DC converter chips, they are not only are they efficient, but they also create more noise. So you're going to have to add more filtering components in order to properly filter that and get some nice clean power. And that takes some engineering. And it's also going to increase the cost of those power supplies. So you kind of do get what you pay for. But from a budgetary standpoint, this type of power supply design is definitely the most superior in terms of in the budget arena. It's much better than a daisy chain. And 99% of the pedals out on the market today, these power supplies will be able to power without a problem at all. The final tip I wanted to discuss is that if you really had a high current pedal that needed to be powered, you can use these power supplies, and you can get an adapter it's called the Y adapter, and it basically will utilize two of the ports here. So if I have 500 and 500, that's how I would get my 1,000 milliamps of capacity in order to run that high current pedal, and it will run just fine. You're just now splitting the current between the two output stages, and that should be more than ample enough where you should not have a problem. It's just a design consideration that if you're going to use two ports to power a single pedal, you got to make sure you have enough ports left here on the pedal power supply to run the rest of your pedals. But it is doable, and it's actually a very common practice, even with the more expensive power supplies. I hope that's been helpful. Guys, if I have missed anything or if I got too technical, please feel free to leave a comment with your question, and I'll do my best to answer it. Big thank you to Caline, as always, for all the support, and thank you to my viewers for supporting my channel. You guys really are a great community to be making these videos for, and I hope to continue to keep on making them. Thanks again for watching, and we'll catch you on the next project.